very dangerous form of wind shear called a microburst was one of the leading causes of aircraft accidents around the world. This sudden downburst of air was identified as causing over 25 airline accidents between 1964 and 1985, resulting in 625 fatalities. With mounting public pressure to help prevent these types of accidents from occurring again, researchers at NASA were asked to develop technologies which would help aircraft detect and avoid these dangerous microbursts. The wind shear detection system that resulted from this pioneering work has undoubtedly changed flying for the better, forever. In the summer of 1985, an all-out effort was made to understand the wind shear phenomenon after another deadly aircraft accident occurred due to wind shear. Within months of this accident, researchers at NASA began conducting tests on systems that could help aircraft detect and possibly avoid these deadly winds. But before a solution could be found, researchers needed to know exactly how wind shear, and specifically the more dangerous microburst wind shear, worked. They understood that wind shear is a sudden change in wind velocity in a given direction. Aircraft often experience these shifts in winds while in flight, but at higher altitudes, they have enough speed and height to compensate. Although, when an aircraft encounters wind shear during a takeoff or landing, it's much more serious. This is because the plane is close to the ground and has very little extra speed to maneuver. In a microburst, a column of air cools rapidly and generates intense downbursts that create powerful wind currents near ground level. These downbursts are especially dangerous because they often mislead pilots into making wrong decisions. When first entering a downburst, the pilot notices a performance-enhancing headwind, which causes him to naturally pull back on the engines. This headwind is then followed by a sudden downdraft, which rapidly pushes the aircraft downward, followed by an extreme tailwind. Because the engines are already at a low power setting due to the pilot's first instinct to throttle back, the aircraft does not have enough power to climb out of the downburst, potentially causing an accident. With this knowledge in hand, NASA researchers knew they had to find a way to give aircraft enough warning to either power up and fly through the wind shear or to avoid it altogether. Since ground-based radar systems already existed, researchers began developing a system to be installed on the aircraft itself. To be successful, this system would need to give pilots at least 10 to 60 seconds prior warning to avoid danger. After years of developing advanced sensor technologies in NASA labs on the ground, it was time to test the system in the air. For these experiments, NASA Langley's 737 aircraft was chosen to be the flying test bed. The only way to accurately determine if a system worked well was to fly the aircraft into a microburst, putting the aircraft and crew in danger. Researchers tested several types of sensors, but a system called forward-looking Doppler radar held the most promise. In June of 1991, the first airborne flight tests were conducted aboard the 737. This research continued through the summer of 1992. But by the end of testing, researchers had successfully developed a wind shear detection system that gave pilots at least 40 seconds of warning prior to entering a microburst. Finally, the wind shear problem had been solved. This system was so successful that a commercial version was available within a year. Today, every major air carrier in the United States has forward-looking wind shear radars installed aboard their aircraft. The wind shear program at NASA Langley has been universally praised by both government and industry as being an invaluable life-saving tool. Perhaps the best praise for this program came from former Langley Center Director Jeremiah Creedon, who said, "This is NASA at its best. We might get that good again, but we can't get any better."